We learned that we have product rules for vector valued functions, and we have different product rules for multiplying by a scalar valued function, for doing a dot product of two vector valued functions, or for doing the cross product of two vector valued functions in 3 dimensions. So none of them should be all that surprising. So the cross product one is the one I'm going to be looking at in this video. The derivative of r1 of t crossed with r2 of t is equal to r1 prime of t crossed with r2 plus r1 of t crossed with r2 prime of t. And so a common question that comes up with this is if you're asked to do something like this, is it easier to just take the cross product first and then take the derivative, or is it or should we actually be applying the product rule here to write out like this and then have 2 separate cross products to take? And so it very well could end up being that in any given problem, like this is the easier way to do it instead of using the product rule. However, there are certain circumstances in which we do want to use the product rule. It does shed some very interesting insight into things. And so let me show just one example where this is a kind of neat, cute little example where we do want to use the product rule because we get a slightly surprising result. So the question I want to ask here is, what is the derivative that we get when we take r of t and cross it with its derivative? So here we have r of t and r prime of t, so this r prime of t is just the derivative of r of t. So let's see if anything surprising happens. So we're going to use the product rule that we have up here. So it's going to be r of t, and I should say that's r prime of t, so we take the derivative of the first function. We cross it with the second function, that's left untouched, the second function is r prime of t, and then we add the first function, we leave that untouched, and we take the derivative of the second function, so the second function r prime of t, so that derivative is the second derivative of r double prime of t. And so that was straightforward enough, but now let me pause for a few seconds to see if you notice anything here that we can simplify what's on the right. Okay, so the thing that you should have noticed was this first term is r prime of t crossed with r prime of t. And if you think back to our 12.4, our cross product rules, we have that if you cross together 2 parallel vectors, or vectors that are pointing either in the same or completely opposite directions, you get the 0 vector. So remember, this was in class, I think we did, let's see if I can remember the exact example. I think we may have done 1, 3, 5 crossed with 1, 3, 5 and got 0, 0, 0. Maybe that was the example we did. Well, so it didn't matter what vector we use here. The cross product of a vector itself is going to be the 0 vector. So this part in here, r prime of t crossed with r prime of t, we don't know what r prime of t is, but we know when you take the cross product of it with itself, we get the 0 vector. And so the right-hand side simplifies down to 0 plus r crossed with r double prime. And so that's just r crossed with r double prime. And so so now we have this rather elegant formula. The derivative of the cross product of r with its derivative is r crossed with its second derivative. That's pretty elegant. And so this video, what's the point of it? It was to show that there actually are some cases in which using the product rule when applied to the cross product, you can actually get some kind of fun stuff with it.